Let's talk about velocity time graphs. We've already talked about distance time graphs or position time graphs. Velocity time graphs are going to look very similar, so you're going to have to be careful and look at what's on your y-axis, because a lot of times those two graphs will look similar when you first look at them. But a velocity time graph, the slope of it will give you acceleration instead of speed. Remember that our slope is always rise over run. For a velocity time graph, that rise is velocity in meters per second, and that run is time in seconds in this case. So the slope is going to give us acceleration in meters per second, or meters per second squared, which we know is both our valid acceleration units. Okay. Remember that when objects are accelerating, they can speed up or slow down. If we have an object with a positive velocity and a positive slope, meaning a positive acceleration, it will be speeding up. But we could also have an object with a negative velocity, and since the slope is negative, it also has a negative acceleration. So it's still speeding up. It's getting faster, but in a negative direction. On the other hand, objects can accelerate by slowing down. If we have an object moving with a positive velocity, right, it's on the positive part of this graph, but it has a negative acceleration because its slope is negative, then that object will be slowing down. Likewise, if it's a negative velocity in the negative part of this graph, but it has a positive acceleration because the slope is positive, then it will be slowing down. Make sure you put this in your notes. This is what speeding up looks like. Either of those two options. Here's what slowing down looks like. Either of those two options. A constant velocity means you're going the same speed in the same direction the whole trip. This means there's no acceleration. Think cruise control, right? On a car. The point of cruise control is to make sure your velocity stays constant, that you're not accelerating by speeding up or slowing down. Okay? So our acceleration would be 0. So whenever we see a horizontal line, our slope is 0, meaning our acceleration is 0 if we have a velocity time graph. Notice all of these have been straight lines. So a straight line tells you have a constant acceleration. But you don't have to. You could have changing acceleration. You could have increasing acceleration, meaning it would curve upward. Or you could have decreasing acceleration, meaning that it would curve downward. Sorry, don't need that. Also, similarly to a position time graph, the slope can help you compare two lines. Here I've got two different objects moving with different velocities or different changes in velocity. They have different slopes. This green one has the greater slope, which means that it has greater acceleration. Its acceleration is changing faster than this red line, which has a smaller slope. So it has smaller or less acceleration. Its velocity is changing, but not as quickly, not as greatly as the green line. And that's pretty much velocity time graphs. In your notes, make sure that you've written down some example graphs. Make sure you know what speeding up looks like and what slowing down looks like. Make sure you know what a constant velocity means and how to compare accelerations using a velocity time graph, and then what it would look like if what curved lines mean. Make sure you have all of these things in your notes. If you don't have them, go back, listen again.